So we have a submarine, and we are submerged in the water, the ocean, so that means we are underwater, okay? At time equals 0, we make contact with an enemy destroyer. So it looks as if we're going to start at 0. We've got to figure out how low we are at 0. Well, we don't know. It just says we made contact with an enemy destroyer. So we don't know where we are at 0. So that doesn't help us start the graph. So we keep reading. After that, we start porpoising, which just means we go deep and then shallow. Deeper, shallow, high, low, like a sinusoid. High, middle, low, high, middle, low, back and forth. At 4 minutes, we're 1,000 meters below sea level. So that is a point we can work with. At 4 meters, we are 1,000 feet below, so that would be negative 1,000. Very important to realize that is negative 1,000. It also tells us at 9 minutes, we're at our shallowest. Now it says next shallowest because there's a bunch of shallow. We're at our first deepest, our first shallowest. Second deepest, second shallowest. Third, fourth, and it just goes on and on forever. So that's why it says next shallowest. So it doesn't say 9 minutes later. It says at 9 minutes, we are at our shallowest, which is going to be negative 200. Yesterday, we started at 1 and 3 seconds later, so we added the 3. Today, it tells us where we are at 4. It tells us where we are at 9. So those are 2 points that we can start with. So here, because I'm below, I'm going to go ahead and label this above. So we have 4, and this is going to be time. Over here, we're going to have distance below the water. Distance below the water. And we can go ahead and draw our y-axis over here to the left of 4. We know that's at negative 1,000, so we can plot that point right there. And that's the lowest, the deepest, yes. Oh, that's a good point. So we could just say distance. Yep. Yep, just distance would be okay right there. Distance below, we could say distance below sea level. So, yeah, maybe just distance would be better right there. All right, so we have that point 4, negative 1,000. Then we know our shallowest is at negative 200, still below that x-axis. And because we're going porpoising, going shallow to deep, that means we're going to go to 9 seconds right here. We're going to skip this one because that isn't the high point. It's the middle right there. We're going to have this middle. Again, if you like to draw that dashed line, draw it. If not, that's okay also. And we're going to have a middle point right there. Then we're going to go back to the middle, and then we're going to go back to low right there. So we can draw our graph, but we still need to plug in some stuff. We need to figure out some more things here. If it took 5 seconds to get from low to high, then it's going to take 5 seconds to get from high to low. So that's going to be 14. And then we have 13 over 2 for 6.5. We have 23 over 2 for 11.5. You have a calculator, add and divide by 2. Don't mess up on that when you have a calculator. Add and divide by 2. Negative 1,000 plus negative 200, negative 1,200 divided by 2, negative 600. All right, so now we have everything that we need in order to write an equation. Now, yesterday, the problems were very specific. It said D equals this and P equals that, so it gave us the little letters we needed to use. This one only gives us the T. So you can use Y, you can use D of T, you can use F of T, any of those. You can't use F of X because there's no X in this problem, it's a T. I'm just going to stick with what we did yesterday and say D equals, because that's the distance. It makes sense that D, the Y value is distance, but Y is okay also. So D equals, I'm going to choose to start this point right here. This is where I'm going to start in order to write my equation. You can start at any of those high, middle, or low values you want. Doesn't matter. I choose to start low, so that's a negative cosine. So I'm going to have negative the amplitude, negative 600 to 200, that's 400. I chose to start low, so that's cosine. I need to figure out what my b value is. That's using my period, 4 to 14. So that's 10 equals 2 pi over b. So 10b equals 2 pi. Divide by 10. Some of you can do this in your head, and that's fine. Pi over 5. That is something you would not want to put in your calculator. You get a decimal and then it not be right. Pi over 5 is exactly what we need to put there. Parenthesis, we do have to use the letter t because that was given in the problem. I chose to start at 4, so minus 4, parenthesis, minus 600. So right there, you would need to use a minus 600. If we are drawing our graph below, really this y-axis is just below it is negative and above it is positive. So this is the water level right here, okay? The distance from the water level. That's probably a better word, distance from the water versus below the water. So if we are below, we need to label it negative. If we are above, we need to label it positive, wherever we are. All right, so we have our equation. Now we just need to use that equation to answer our questions. So we have to plug that into the calculator. Remember, we clear your calculator. I would clear my calculator when I do these problems. I clear my calculator every time. That way it goes back to blank. I don't have to worry about anything. I know it's in radian mode. And I can do all of that calculation without having to worry about it being in some crazy mode. All right, so y equals, you don't have to put it in y equals, I just do. I don't want to type in this formula more than once. So negative 400 cosine, make yourself a little fraction if possible. If not, this has to go in parentheses. So second pi, what do we get, over 5. And then open your parentheses again for your x minus 4. Close, close. Very important to close, close right there. You have to open, however many times you open, you have to close, or that minus 600 is going to be included in that parentheses, and we don't want that. Be sure you're using, someone earlier used a negative sign right here instead of a minus 4. That threw it all off, because then that changes to negative 4x versus x minus 4, which is very different. So again, negative sign and minus sign doesn't mean the same thing in the calculator. All right, and we want to find where is it at 6. So second graph, we want to go down to 6. And our answer, negative 723.6, but we round to the thousandth always, unless we're talking about things. On your homework, there's a fox. You can't round a fox. You can't even say part of a fox doesn't round up to be a whole fox. That would be a situation when you truncate. You ignore the decimal. Here we are not ignoring the decimal. So how do I know what the rest of that is? Well, I just go and highlight it, and now that whole number shows up. So now I can round correctly. Negative 723.607 feet. So at 6 minutes, we are at negative 723.607 meters. Or we could say 723.607 meters below sea level. That would be okay also. Either one of those would be okay. If you answer with the negative, then we just have to say meters, or you can say 723.607 meters below sea level. And then we do the same thing for 15. We can scroll down to 15. Now some of your older calculators, if you're on the Y, it won't let you scroll on the Y. If it doesn't let you scroll on the Y, scroll back over to the X, and then just go down. And again, highlight that answer right there. Not the only way to do it. Since we put this into y equals, We could also go to remember our vars, y vars. We put our equation in y1. We can make it like function notation. We want to know y1 of 15. Get our answer that way. We can store 15 as x, and then just go vars, y vars, and get our answer that way. Now 15 is stored as x, so it's going to plug x in for us, and we can get our answer that way. Lots of ways to get your answer, not just one way. You can go to the table and ask, the independent ask, you can do all of those things. So negative 923.607 meters, or 923.607 meters below sea level. Either one's okay. All right, the next question. Your submarine is safe when it is 300 meters below sea level. We want to know, is it safe at time equals 0? Okay, well, we know time equals 4 right here, but remember, this curves back up, so we don't know if it's safe. Our picture is not anywhere close to scale, so we can't look at our picture and figure that out, so we plug that into the calculator. It is giving us T. We need to know what is D, and that would be our work. What is D? If you can figure out what D is, write that down. That will justify your answer of yes or no. So all we have to do is go to our table of values, look at 0. Again, we can do this lots of different ways, not the only way to do it. And right there, negative 276.393. Negative 276.393 is what our distance from the water is at time equals 0. It tells us we're safe when we're 300 below. We're only 276 below, so our answer is no. So this number written down, that is the work for that problem. You're writing that number down, and it doesn't even have to be, that number is not part of your answer. I don't have to see if it's rounded wrong, that doesn't matter, because that is not your answer. Okay, but writing that answer, writing that number down in some way will be the work to justify your yes or no answer. Very seldom does yes or no work without some kind of work shown at all. Now, these other two, our work was the equation. We already had the equation. So you did all the work up here, and then you just plugged 6 into your calculator, you plugged 15 into your calculator. That was sufficient. But this one had one more thing you had to find, so we had to write down what that number was in order to answer the question. All right, so this next one, a little unrealistic, so just got to go with it. We have 200 million people jump up or step up on a table. Everybody in the U.S. steps on a table at the same time, and then go, we all jump off, okay, which creates this shock wave. It tells us what the period is, which is nice. We want to find that. It tells us the surface first moves down from normal and then up from normal, and it's equal. It goes up and down, equal position. Okay, and it's a shock wave, so it's going to go up and down over and over and over again. It also tells us that our amplitude is 50, so that's nice. We know our A value already. And so we need to graph this. So if at time equals 0, no one's moved anywhere, we're all standing there at 0, we're at normal. So at 0 time, we are normal. So distance from normal. Position. So 0, 0 is a point. Everything's normal before anything happens. Nothing happens, so we're all normal. Then it says the surface first moves down from its normal position. Okay, so if it moves down, we know the amplitude is 50, so we're going to go down 50 and up 50. So it first moves down, Then it moves up, so middle, high, and then back to middle. So there's our sinusoidal function that we just created. It also told us that the period, one cycle, was 54, so we know start to finish is 54. Half of that is 27. 27 over 2, 13.5, whichever one you like better. 81 over 2, whatever that is, what, 40.5? Yep, 40.5. Either one's okay. Again, if you can simplify, simplify. 2 does not go into 81, so that is simplified. Changing something to a decimal doesn't make it simplified, it just changes it to a decimal. All right, so we have our 5 critical values. We have our y-axis in the correct place. We have the 50 and the negative 50. We've drawn the actual graph. Don't forget about drawing the graph. We have our x and our y-axis labeled here. Only letter it gave us was t, so that's the only letter we have to use. If we want to use y, we can use y. We can use f of t if we want to use function notation, d of t, whatever you want to do. I'm going to just use d. Distance equals. So I'm going to start at 0, 0. This is going to be where I decide to start when I write my equation. You can start at any of those high, middle, or low. Any of them, doesn't matter. So because I decided to start in the middle, that's a sign. It went down, so that's a negative sign. So negative 50 sign. I know my period is 54 equals 2 pi over b. Again, a lot of you are really good at this point. You know what to do. If not, 54b equals 2 pi. Divide by 54, and we get pi over 27. And then c was 0, d was 0, so just t. So there's your equation. The t has to be there. The d, it's up to you. Y equals, d equals, d of t equals, f of t equals. Any of those would be okay. Not f of x, because there is no x in this problem. All right, what is the displacement when t equals 21 minutes? Okay, so we want to know, at 21 minutes, what is that displacement right there? So in our calculator, y equals, we can clear that out, negative 50 sine pi over 27 x. Now, because there's nothing after it, whether I close these parentheses or not, it doesn't matter. There's nothing being added or subtracted, so that parenthesis right there does not matter. Something being added or subtracted, very important to close it. If not, it doesn't matter what you do. All right, so we want to know at 21, so we can go to our table. I don't want to scroll 23 times, so I'm going to go second window, and instead of ask, I'm just going to type, I want it to go to 21. So I can start my table at 21, so I can just look at my value. Again, I can't see that whole number, so negative 32.139. Notice here it says 0.14. Well, we round to the thousandth. That's not to the thousandth, so we look here. Negative 32.139. That 3 doesn't move that 9 up. It stays the same. So we can say negative 31.139 meters, or we can say 31.139 meters below normal. I'm okay with either one of those statements. Oh, what did I do? 32? Did I write the wrong number? I did. What was my number right there? Oh, 32. Yes, please do. Please write 32. You cannot. No. Okay? 32.139, a 3 does not make a 9 go up to a 4. Okay, so no. That would be all wrong, because that's more than 1/1000th off. Okay? If this was a 5, a 6, a 7, an 8, or a 9, then that would be yes. Okay? So 139, we look at the fourth number. The fourth number tells you whether the third number goes up or stays the same. Okay? 5 or higher, it goes up. So 139, actually if you did 140, that'd be a point off because that's a 1/1000th off. So it'd be a point, but no need to get a point off. Okay? Always rounding to the thousandth. Money would not be appropriate to round to the thousandth. That would be the hundredth. Foxes, there's your homework. Talks about a fox. Talks about rabbits, elephants, people, chairs, tables. Can't have part of those. You truncate. Truncate means you ignore the decimal. So if we were talking about something, and like at 28 we wanted to know these were 5 people, it would just be 5 people. That wouldn't be 6 people. 0.8 of a person doesn't make that 6 person. Okay, so if this was talking about our y was people, we would just say 5 or 5 rabbits or whatever it is. Okay. All right, what are the first 3 positive times at which the displacement is negative 37? So again, think about our graph up here. Here is negative 37, so here's 1, here's 2. Well, I don't have another one. Well, I do. This graph keeps going, so I do have another one. It's just past 54. So we should, kind of have an idea of what our answer should be according to our graph. Something less than 13, something a little less than 27, something bigger than 54. Those should be our answers. They're going to make sense. If your answer doesn't make sense. Earlier today I made a mistake on my, when I put this in, and I got like, at 21, it was like negative 150. Well, I knew that was wrong, that I did something wrong, because I knew I couldn't go down negative 150. The lowest I went was negative 50. So these word problems are nice because you can kind of have an idea of what your answer should be. Not exactly, but they need to make sense. All right? So when we go to our calculator, again, we need the first 3 positives. So here is, if we graph it, that's all we got because our graph is from negative 10 to 10. And we see that we're negative 50 to 50, and just one cycle is 0 to 54. So when I go to my window, I want to see more. So my window, I don't care about negative time, so I'm going to make that 0. On the graph we drew, the max was 54, so I'm going to make that bigger. I'm just going to make it 100. Then I need to see at least down to negative 50, so I'm going to make that negative 60. And at least up to 50, so I'm going to make that 60. And now when I graph it, I should be able to see the whole graph. And then some. I want to know when does that graph hit negative 37, so I go to y equals. And negative 37, if you're trying to hit the minus sign right there, minus 37, and you go to graph it, gives me an error. My calculator's not broke. I'm broke. I don't know what I'm doing right now, okay? So there's an error. Notice it says quit or go to. If it says go to, go to. It's going to go to your error most of the time. Sometimes you have more errors and it doesn't. But, okay, well, what did I do wrong? I don't know what syntax means. Your answer's never syntax, okay? Don't ever put that on your paper, ever. So, 2. I'm going to go to my error. It's flashing on my error. That's where I messed up. I put a minus sign instead of a negative sign. Now when I graph it, it's going to do it for me. So here is the first time it's negative 37, the second time, the third time. So I just find all those points of intersection. Second, trace, 5. I need my cursor to be over on this first one. And you can hit like 1 and it'll jump to 1, or you can scroll. Either one. Again, you just need to be closer to it. Enter, enter, enter. And there's your first answer, 7.160, because that 7 moves that 59 up to 60. So 7.16 or 160, and we're in minutes. And then second trace 5. We need to move over. to our next one. Enter, enter, enter. 19.84 minutes. And then it asks for a third. Second trace 5. Scroll over. I don't want to scroll over on I don't want to scroll on that curve. I want to scroll on the line. So again, the up and down is what goes from one to the other. And I just need to be closer. Enter, enter, enter. 61.160 or 16 minutes. You do not have to put the 0 at the end. If you want to, you can. Now, another thing just to kind of note. This is a sinusoid, so it's going down and up over and over again. So this was on our way down. This was on our way down. The same point that starts to repeat, just like our high, middle, and lows repeat, this repeats going down, it repeats going down. So that is the period away from each other. So if we took that 7 number and we added was the 54, we would get that 61 number. That happens. That's not a coincidence that those two numbers are the period apart from each other. That will happen every time. Now these first two aren't, because that's not a period. It's got to go down and up. The downs are the period apart, the ups are the period apart, and then downs, ups, and that will keep happening forever. So if it was like 10 places, you could just keep adding the period to get those answers. Just like with asymptotes, you could just keep adding the period to find asymptotes. They just keep happening over and over again. All right? Very important that you practice the calculator.